Algebra, the Saxon HomeSchool final exam or placement. It's really good. It's a nice broad view of all the things, not all the things, of many things that students should know coming out of 7th grade, having mastered PreAlgebra. So we look at here divisibility rules. These are really important, very, very common. And you should know divisibility rules for, let's just get this pen a little bit teenier. You should know the 2 divisibility, 3, 4, 5, 6, not 7. 7's almost impossible. It's just as good to just do it by hand. 8, 9, and 10. Those are the divisibility rules that you should know. You should know all numbers that are divisible by 2, 3, 4, 5, 6, 8, 9, and 10. So use the rules of divisibility to tell if 71,655 is divisible by 3. Well, the 3 rule is the sum of the digits. Sum of the digits is divisible by 3. So it's nice because you don't have to do the whole number. What you're doing is you're adding 7 plus 1 plus 6 plus 5 plus 5. And if you add those numbers together, you get 24. And the question is 24 divisible by 3? And yes, it is, by 8. Now the answer isn't 8, but it just means that it is divisible and it's worth your time to divide this, right? We wouldn't want to spend time if dividing a number by a number if it's not even going to work. So if it's not going to produce a whole number, so hence the divisibility. So yes, it is not 24. 3 divided by 71,000 or 71,655 divided by 3 is not 24, nor is it 8. It just is divisible by 3. And then the 5 rule is any number, these are relatively easy, number ends in 5 or 0. Let's do or 0. Yeah, so this number ends in 5, so it is divisible by 5. Divide, round the answer to 2 decimal places. So there's a lot of different ways to do this. I'm going to show you one. You can use partial sum. Partial sum is a little advanced because it's decimals, and not many students understand decimal partial sums or partial division. No, what is it called? I don't know. Divisibility, division, sum of the division. I don't know. It's where you multiply by nice numbers. You learned it in everyday math. I like it. It's fun. But we're going to divide 61 into 431.25. We're going to put the decimal point there, and then we're going to look at the first number. It doesn't divide by 4. 61 can't go into 4, can't go into 43. The first number that it can divide into is 431, and 7 times 61. Honey, but I'm making a movie, babe. You're on my movie. 61 times 7, 427, so 427, and we're going to subtract. And 7 gives us, well, we got to borrow. Can't subtract 7 from 1, so we borrow, so that's 4, and that's 0, 0. We bring down the 2. Now, 61 doesn't go into 42, so we have to take up that place because we need to bring down another number. 425, so 61 goes into 425. Let's do 6 times. So 61 times 6, 6, 36, 366. 366, subtract, gives you have to borrow. That's 9. You got to borrow. That is 5. 59. Let's add a 0 and bring it down because 61, yeah. So 590. 590. Oh, I forgot to put the 6 there. Sorry. for my 366, and then 590. Let's see, 590, so that's going to be 7. What about 8? So 61 times 8, that's 8. 48, no, let's do 61 times 9, that's 9, that's 54. So, okay, that's 9, so 9. So 549, can't, so that becomes an 8, that's a 1. That's, I think, an 8, so 41. All right, now it says round to 2 decimal places. So we don't have to keep going. We're done here. We don't have to keep going, even though that's going to continue on. But we had to go out to the tens, hundred, the thousandths place in order to round to the hundredths place when it says round the answer to 2 decimal places. So I'm going to look at that. So my number is 7.069, ... keeps going. I'm going to round to this place. I look here. That tells me to round up. So my answer is going to be 7.07. That's how we are going to divide. That's an old school method. Not a lot of people know that. If you look at, I guess there's going to be detailed answers. I don't have a picture of it, but I'd show you the partial sum. That's kind of fun and crazy, but for another day. Number 3, simplify mentally. So when we divide by 1,000, we have 3 zeros, and each 10 is going to move this decimal point 1 place. So that's 1, that's dividing by 10, that's dividing by 100, that's dividing by 1,000. So each decimal place is represented by 10. So we just sort of mentally walk through that. Now, same thing goes when we multiply by 10, we're going to move the decimal place 1 place to the right. It's going to make the number bigger. So that's 10. This is 100. We move it 2 places, 2 zeros. So we get 1128.36 would be our answers. Nice and efficient. And these are fluency. This is number sense. These are things that you should really know inside and out, and it saves you time. I think students tend to rush through this type of stuff, and this rushing really hurts you and hinders you later on in the more advanced math. If you haven't taken the time to really work through numbers inside and out and lots of repetition, and you're rushing to get to calculus, you're not going to do well later on because you've skipped all the important foundational work. So take your time with this and work through it and do lots of repetition and lots of practice. Write 6/15 as a fraction with a denominator of 20. So really what we're, sorry about that. Really what we're doing is we're converting an equivalent fraction. We can do it this isn't really nice because no number times 15 equals 20. So you can reduce this. So 3 goes into both of these, and 3 goes into 6 twice, 3 goes into 15 5 times, and now you have a much easier number to manipulate. So in equivalency, we can multiply it by 4/4, and we get 8. So write a fraction with the denominator of 20. So 6/15 is equal to 8/20. That's a fraction equivalent with a denominator of 20. So again, knowing how to manipulate fractions, how you can simplify or convert to a different, we can reduce it and then make it a little bit more, a little bit easier to go through. Find an equivalent fraction, right? 720 over 2,000 is a product of prime factors and simplify. So we're going to do prime factorization. Prime factorization is breaking a number into its prime factors. We can do it a whole number of ways. I'm going to break it into 72 and 10. There are no specific, you just have to, it has to be a product that creates that. I chose 72 and 10 because that's the easiest. We have 8 and 9. These are not prime numbers, so we're going to have to keep breaking those down. 4 and 2. 2 is prime, 4 is not prime. So this is, I circle them just to know that we're done. And these are prime numbers, so 9 can be broken into 3 and 3, 10 can be broken into 2 and 5, those are prime. So 720 in its prime factors, and I always put them in numerical order. It's 1, 2, 3, 4 2s, 2 3s, and a 5. So if we multiplied all that out, that would produce 720. And notice all of these numbers are prime numbers. You wouldn't want an 8 up there because that's not a prime number. And then we're going to break up 2,000. So I'm going to do 2 and 1,000 because 2 is a prime number. And I'm going to do 2 and 500 because 2 is a prime number. I'm going to do 2 and 250 because 2 is a prime number. And I'm going to do 2 and 125 because 2 is a prime number. And then I'm going to do, oh, let's do 5 and 25. And then we'll break 25 into 5 and 5. So we get 1, 2, 3, 4. So we get 4 2s again, and then we get 3 5s. So now we want to simplify. So simplifying, we're going to cancel, 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 cancel. Those don't make zeros, those make ones. 2 over 2 equals 1, and we're multiplying it, so it's not really going to affect it. And this cancels to make a 1 also. And we are done, and we are left with 9 over 25. And no number goes into that. So that is its simplification. It's a fun one. Again, good number sense work here. Use words to write the number 7,821 and 8,218 ten thousandths. So we write this 7,000. No end here. 7,000, pause, comma. And then we do 821, 821 dash 1. And the end represents the decimal point. And now we read it as if we just see that number. You see those 4 numbers. That's 8,000. $218, DRED, 18. And now you go out to the place. So that's tens, tenths, hundredths, thousandths, ten thousandths. So you're going to put that 10 thousandths. And if you take the time to learn this, it's actually quite easy. It can be confusing, it can be overwhelming, but for the most part, it can be, once you find the technique and the trick to it, it actually becomes quite simple and relatively straightforward. Number 7 says the average time for 4 400-meter runs was 53.4 seconds. If the first run was 52.7 seconds, the second run was 53.3 seconds, and the third run was 54.1 seconds, what was the time for the fourth run? So I like reading the problem first. And so we have an average of 4 runs. We're provided 3 of the 4 runs. And so we have to find out what the fourth run is. Well, we know when we average 4 things, we do the sum, or let's do this, sum of the times divided by the number of runs equals the average. So we know what the average is. Now we start substituting. The average was 53.4. The sum of the times, well, we have 52.7 plus 53.3 plus 54.1 plus my fourth run, and then we divide it by 4 because there were 4 runs. So now we want to solve for this variable. that is being added and divided. Now, this long division is really a vinculum. It's saying, hey, we have to add all these before we divide by 4. So I got to get rid of this 4. So I'm going to actually multiply that by 4. So that's the inverse operation. Okay, go away. So we're going to divide by 4, because that's going to get rid of this 4 in the denominator, is going to get rid of a 4 in the numerator. And it leaves me with these 3 times plus my unknown. If we add those 3 times, we get 100. Ooh, that's a really thick writing. I don't like how thick that is. So if we add 52.7, 53.3, 54.1, we get 160.1 plus x equals, and 53.4 times 4 gives me 213.6. And why did I add those up? Well, I don't want to subtract each one, right? I could. It would end up being minus 52.7 to both sides, minus 53, but it's just easier to add them and then subtract one nice value, because we want to isolate our variable. So that number is being added to x, so the inverse of adding 160.1 is subtracting 160.1. That leaves me with my variable, and then we borrow. Whoops, sorry, didn't need to borrow. Sorry about that. No borrowing needed. We can take 1 from 6, that gives me 5. 0 from 3 is 3. Now we have to borrow. That's 5. So 53.5 is my 4th time. So the 4th run time was 53.5. And what was the units? Seconds. When we're given a word problem, we give a word answer. That's always the best. And we look and see, it asks for what is the time of the 4th run. The 4th run time was 53.5 seconds. Good. Number 8, what number is 7/13 of 143? So when we see this, it's asking x, what number is equals 7/13 of 143. So we are not going to multiply 143 times 7. We're going to try to reduce this fraction first by cross canceling. And we see, is there a number that goes into 13 and 143? Yeah, 13. 13 goes into 13 once. 13 goes into 143 11 times. And now we've simplified everything. So we get x equals 7 times 11 is 77. 1 times 1 is 1, and we just leave it as 77. So that number is 77. So if we wanted to take 7/13 of 143, we would get 77. Number 9, write 107 over 13 as a mixed number. This is an improper fraction, and we're going to see how many 13ths go into 107. So we're going to divide 13 into 107. 13 doesn't go into 1, doesn't go into 10, goes into 107. Let's try, what's that? Let's try 8 times. 3 times 8 is 24. 104, that's pretty good. That's 8. 104. We're going to subtract, that's 3. We'll take the leftover and put it over 13th. So 8 whole with 3/13 left over. And make sure this fraction is reduced. You would never want to leave it as an unsimplified fraction. So 8 3/13. Number 10, find the LCM, least common multiple, of 16, 21, and 24. We're going to go back to prime factorization, and we're going to break up these prime factors into prime factors. So 16 is 2 times 2 times 2 times 2. 21 is 3 times 7. 24 is 2 times 2 times 2 times 3. Now you go, Mr. Mack, how did you know that? Well, I've done prime factorization so much that I can do a lot of the common numbers, 16, 21, and 24, are relatively small instead of doing it off to the side and doing 4 times 4 and 2, circling, 2 and 2 and circling, and then coming up with 2 times 2 times 2. I just know it because I'm very familiar with it. So now LCM is least common multiple. So the C stands for common, but it reminds me to circle the common. So I'm going to see, what do all 3 of them have in common? They don't have anything in common, but we do have some that have in common from 2. So these 2 share a 2. This shares a 2. This shares a 2. And, well, let's do it a different color. And then these 2 actually share a 3. So that shares a 3. So the LCM, the commons, are, I went big again. The common is 2. We have a second 2 and a third 2. And then we actually have a 3 in common. And now let's do the last one. So the L stands for least, but I think of leftovers. So what's left over here? Well, we have a 2 left over and a 7 left over. So then I include my leftovers also. And that will produce my LCM. It's a nice, efficient way, 100% certain on what my LCM is. So 2 times 2 times 2 is 8, times 3 is 24, times 2 is 48. 48 times 7 gives me 336. So the LCM, the multiples of 16, 32, 48, etc. 21 is 21, 42, 63, etc. 24 would be 24, 48, etc. Those are multiples. Which one did all 3 have in common would be 336. So nice, efficient way. I am 100% certain that that is the LCM. So having a technique is going to be important that you can rely upon, that is efficient, that you're familiar with, that you just go and you hit it running, and then you'll be done in a much more efficient, faster way than listing all the multiples of a number. So we have to simplify. So there's lots of things going on here. We have multiplication, division. When we have orders of operations, tells me to do multiplication, left to multiplication, division are equal, but we do them left to right. These are all mixed numbers. We're going to have to turn them into improper fractions. So 4 times 6 is 24, plus 3 is 27 fourths, and 2 times 3 is 6, plus 1 is 7 halves. Now we want to try to reduce. Those don't reduce, but what we can do is we can leave it as 27 times 7 over 4 times 2. Mr. Mac, why don't you multiply them? Well, because I got a lot of other math to do over here. So I'm going to divide. Well, there is no division. We know that when we divide, we are going to multiply, convert it to multiplication by taking the reciprocal of this term. We can't take the reciprocal until it is an improper fraction. So 5 times 3 is 15, plus 3 is 18 fifths. So now we're going to take the reciprocal, so that becomes 5/18. So that's times 5/18. And then we're going to also take that and we're going to convert that to multiplication. And again, we have to convert that to an improper fraction. 4 times 3 is 12, plus 3 is 15 fourths. And then when we convert from division to multiplication, we're going to take the reciprocal, so that is 4/15. So 4/15. And again, I'm not multiplying everything out because I want to be able to cross cancel. Why? I mean, right? Why multiply if we're just going to break it down eventually? So I like leaving it like this so I can cancel denominator, numerator. Ooh, 5 goes into 5 once, 5 goes into 15 3 times. And then 3 goes into 27 9 times, and 9 goes into 18 2 times. And we're left with a 7 a 1, a 2, and a 2. So my answer is going to be 7 over 4. I didn't have to use a calculator. I was very, really good about accurate, and I reduced big numbers to make very small manageable numbers. Instead of multiplying 27 times 7 times 5 times 4 and getting this really large number here, and 4 times 2 times 18 times 15 and getting a real big number, what are we going to do with those? We're going to reduce them. We're going to look for a common factor. It's much easier to find common factors when the numbers are broken down. So this is a really good technique. Use 4 unit multipliers to convert 630 square yards to square inches. Now this is a trick question. You're not just doing yards to inches because it's squared, so it's 2 dimensions. So when you convert in a 2-dimensional, you have to convert both the length and the width. So when you have 630 square yards and you're going to convert it into inches, well, first of all, we got to go from yards to feet, square yards to square feet. So 1 square yard is actually equal to 9 square feet. Because you go, Mr. Mack, it's 3. 3 feet equals 1 yard. Yeah, but remember, it's 2 dimensions. So when we have 1 yard by 1 yard, we are converting 3 feet and 3 feet. Hence why that 1 square yard equals 9 square feet. Don't know if you know that. That's a really, think about that. Think about it. Real good, important thing. So now we've canceled yard squared, and now we're in feet, but we want to get to inches, so now we have to convert from feet to inches. So feet's in the numerator. What's going to get rid of a square foot in the numerator is a square foot in the denominator. And now we have to go square inches. So same thing again. 1 square foot is actually equal to 144 square inches because we have to increase both the length and the width. It's a 2-dimensional increase, and you would just use the same. Think about it. If you have 1 foot by 1 foot, that creates 1 square foot, and then we know that 12 inches is equal to a foot, and we would have to convert both sides of that, so we get 144 square inches. Okay, that cancels the foot. Now we're in inches squared, and then we do 630 times 9 times 144, and it doesn't want to know. It says use 4 unit multipliers. I like this. This to me makes more sense. I use 2. You could do 3 feet. I mean, I don't like that. That would just, that's too complex. I'll show you what they're talking about. You do 630 yards squared, and you do 1 at a time, because you do 1 yard by 3 feet. But notice this cancels 1 of the yards and only 1 of these yards. So you're still in yards, and you'd have to do it again. So I think that that's very inefficient. So you would do 1 yard again and 3 feet, because you still have that 1 more yard. Now we can cancel that, and now you're in square feet because it's feet times feet. To me, that's not as logical. This is more logical with the think about, and we're getting rid of yards squared, and then we needed an equivalency, a conversion box with an equivalency. So that's how I did it. I think that it's more of a high school way, and Mr. Mack's going to tend to teach you more of the high school technique opposed to the elementary technique. It's just you're moving to high school, you're not moving to elementary school. So I'm always gonna tear up then tear down, and not tear or crying tear, T-E-I-R. Joey hid them in bunches of 24. In all, he hid 503 bunches. How many did he hide in all? Well, if he hid them in bunches of 24, so one bunch, this is a little confusing. I don't like the verbiage here. It's not the best, but one bunch, a nice way to think about it is one bunch equals 24 items. So if he had 503 bunches, how many items does he have? Well, he's going to multiply it by 24 because each bunch is equal to 24. So if we multiply it, we get 12,072 items in all. A lot of people would divide 24 into 503, thinking that one hid them in bunches of 24. Yeah, bunches of 24. Yeah. I see it in this way. 503 bunches. So I can understand how you might get that problem wrong, but that's the proper way. Number 14, simplify. We're just subtracting, so we're going to align. I always like this. We're going to subtract 198. We're going to add a 0 there for the tens, hundred, thousands place. We can't take 8 from 0, so we have to borrow. We borrow from that place. It adds a 1 there, so now we can subtract 8 from 10. 9 can't take from 7, so you borrow, and that's going to give you 8. 1 from 1 is okay. We bring down our decimal point. Can't borrow 7. Can't take 7 from 1. You got to borrow. That's going to give us 4. Can't take 3 from 2. You got to borrow. That's going to become 9. Then we bring down 5, 2. So 2,594 and 82 thousandths. That's how you read that. Number 15. We are going to say what decimal part of 560 is 70. So we do 70 over 560. Now you can reduce this. You can reduce it by 10 over 10 to get 7 over 56. And then we can reduce that by 7. And 7 goes into 7 once. 7 goes into 56 8 times. And then when you get 1/8, you should know that that's equal to 0.125. You should know that conversion. You should know that fraction to decimal conversion by heart. That is something you should know. You should know anything over 2. You should know all the thirds. You should know all of the fourths. You should know 1/4. You should know 3/4. We wouldn't do 2/4 because that's 1/2. You should know fifths. 1/5, 2/5, 3/5, and 4/5. You should know. Should you know 6? You should know at least 1/6. Well, 2/6 you should know. 3/6 you should know. 4/6 you should know, and 5/6. Yeah, I don't know about 5/6. Sevenths, definitely not sevenths. Eighths, yeah, you should know 1/8. 2/8, no. 3/8, yes. 4, no. 5/8, yes. 6/8, no. 7/8, yes. You understand the other eighths are already over here. Ninths, yes, you should know all ninths. Ninths are easy. Those are repeating. No, we don't do 3/9 because that's 1/3. You should know 3/9, 4/9, 5/9, 6/9, 7/9, 8/9. You should know all ninths. And tenths, yes, 1/10, 2/10, 3/10, 4/10, 5/10, nope. 6/10, no. 7/10, yes. 7/10, 8, 9/10, yep. You should know 10. So those are the fractions that you should pretty much know by heart on automatic converting. So just giving you a little measure of what the depth of your knowledge should be. Patton's troop, that is colonel, that is general, 4-star general. I think he only made 4-star. I don't think he ended up being a 5-star general. But General George Patton's troops covered the first 48 miles in 4 hours. He then increased the speed by 8 miles per hour. If the total distance of the trip was 108 miles, how long did it take to finish the trip? So George S. Patton was a general in World War II. Very famous, very cantankerous person. Great movie, Patton, starring, can't remember the actor. I can see him. Real good. Nope. Can't remember his name. Very good actor, though. Patton's troops covered the first 48 miles in 4 hours. He then increased the speed. So we have to do miles per hour. So 48 miles per 4 hours. Tell me what that rate is. Unit rate, we're going to reduce it by 4 to get a unit rate of 1 hour. So that's going to give me 12 miles per hour. So in that time, he was traveling 12 miles per hour. Then he increased his speed by 8 miles per hour. So we're going to add 8 to that. So he is going 12 miles per hour. If the total distance of the trip was 108 miles, how long did it take to finish the trip? So we have to take the 108, and he's already traveled the 48. So that leaves us with 60 miles that he was traveling at 20 miles per hour. So how long did it take for him to do 60 miles at 20 miles per hour? Well, if he travels 20 miles in 1 hour, he'll travel 40 miles in 2 hours and 60 miles in 3 hours. So it took him 3 hours to go that 60 miles. So the first 48, it took him 4 hours. And then the additional 60 miles, that took him 3 hours. So how long did it take to finish the trip? Well, it took him 3 hours to finish that 60 miles. So 3 hours to finish the 60-mile trip. Because that's how many miles he had left. Yep. Like that. Think about it logically. Draw it out. Make it a picture. Get it somehow. I love this problem. These are called superfractions, when you have a fraction in a fraction. So I'm going to deal with this before I deal with this part of the problem. So I have 6/7 divided by 12/21. And I'm going to convert this. I'm going to write this as 6/7 divided by 12/21. And then I'm going to convert the division to multiplication. So that gives me 6/7. We're going to keep switch flip, I think is what Mrs. Poole teaches you. So we're going to flip that. And now we're going to reduce. Instead of multiplying 6 by 21, we're going to simplify this. 6 goes into 6 once, goes into 12 twice. 7 goes into 7 once. 7 goes into 21 3 times. So this equation now becomes 3/2. So this side is really 3/2 equals 4 over x. Much, much easier to solve this problem. And we are going to use cross product. Cross product. We know that the cross product of fractions should be equivalent in equal fractions. So we're going to write an equation. We're going to do 3 times x equals 2 times 4. 3x equals 8. Divide by 3, divide by 3. X equals 8/3. And that's the answer. So something that looks super complex. We could have cross product here, but let's take care of it. It's not a bad thing. You could cross product and simplify there and then isolate, but I like that. To me, that seems a little bit more straightforward. Complete the table. Begin by inserting the reference numbers. So 68% is equal to what as a fraction? Well, As a fraction, 68% is 68 over 100. We can't leave it as 68 over 100. We're always going to reduce our fractions. And that becomes 34 over 50, which becomes 17 over 25. So the fractional value is 17 over 25. And decimal 68 hundredths would look like that. Or we know that we would move the decimal point, which is here, we'd move it 2 places to the left, and we would get the same number. So either technique is acceptable, but those are our 2 values. Oh yeah, I also enjoy these types of perimeter and area. So perimeter means the distance around the object. So when we want to find the perimeter of an object, we have to find this distance. So the distance around the object. So I'm going to sort of look at certain things. I have some straightforward things. That distance is 10. This distance is 11.2. This distance is 15. So the only thing that we really got to figure out is this distance around the circle. So we know that distance around a circle is called circumference. So what is the circumference? And then we don't want the full circumference. We want only half of it. So circumference equals 2 pi r. And why did I use 2 pi r? Because I was provided the radius. If I was given the diameter, I would just use circumference equals pi d. These are formulas you should have memorized by 7th grade. So here's the other thing is I only want half of the circumference. So I'm going to divide by 2. So technically this distance is really going to just be pi r. So pi is 3.14 and my radius is 5. So that's 20, that's 7, and that's 15.7. So this distance is 15.7 yards. So I have 10 plus 11.2 plus 15 plus 15.7. And all of those distances add up to 51.9 yards. So that is going to be my perimeter around the object. We're going to copy this page. Let's copy it. Copy. Oh, let's clone the page, excuse me. So let's clone it. Let's erase this ink from it. And now let's do the second part. So the second part wants to know the area. So we have 2 objects here. We have this trapezoid, which you should know the area formula for. And then we have the half of the circle. So we have an area of a trapezoid and the area of a half circle. So we should know those formulas. So area of a trapezoid equals height divided by 2 times the quantity b sub 1 plus b sub 2, where b sub 1 is base 1 and b sub 2 is base 2. The bases are the parallel sides of the trapezoid. So let's fill in that information. So let's do this too. We need to know some interesting. So base 1 and base 2, these are the bases. And the other tricky part of this is the height. What is the height of the object? Well, the height has to be perpendicular to the bases. So this is going to be my height. And we know that this distance is 5 and this distance is 5. So my height is actually going to equal 10. So now I can fill in those pieces of information. And we get area equals 10 divided by 2 times the quantity b sub 1, 15 plus 10. We get 5 times 25, and we get area equals 125 yards squared. All right, so that's going to be our that's going to be the area of this region, the trapezoid. So that is this space here. And now we're going to find the area of the trapezoid, or of the half circle. So area of half circle. So area of a circle is pi r squared. So if we want half, we're going to divide by 2. So pi is 3.14. My radius is 5 squared divided by 2. And we get 3.14. 5 squared is 25 divided by 2. 3.14 times 25 is 78.5 divided by 2 is going to give me 39.25 yards squared. So that is going to be the area of half of a circle. So that's this part of the object. So we're going to take those and we're going to add them together. We're going to take this area plus this area. 125 plus 39.25 gives me a grand total of 164.25 yards squared. Would be the area of the object. Cool. Good. Number 20. This is going to be a long video. Good video, but long. Number 20, round 0.000457 to the nearest millionth and write the rounded number in scientific notation. So we have tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths place. So that's our millionth place. So we look to the right. That tells me to round up. So we get 0.00045, and the 6 now becomes 7 because we rounded up. Now we need to write this number in scientific notation. So scientific notation needs to be between 1 and 10. It has to be less than 1 or less than 10, and it can be greater than or equal to 1. So it's between 1 and 10. It's a single digit. So here's my decimal point. Is it between 1 and 10 right now? Nope. I move it one place. If I put the decimal point there, would it be between 1 and 10? Nope. Is the number between 1 and 10 now? Nope. How about now? Nope, that's 0.4. How about now? Yeah, 4.57. That's between 1 and 10. So there's my number. So my number is going to be 4.57. And now every tenth that I made, every decimal place is a tenth or 10. Since we made a smaller number bigger, where is that small? This is a really small number. And now this is a big number. So where did the smallness go? So we have 1, 2, 3, 4. Is it 10 to the fourth or 10 to the negative fourth? Well, if we wrote 10 to the fourth, 10 to the fourth is a really big number, right? 10 to the fourth is a 1 with 4 zeros. So that would make it that's big, and that would make this number bigger. Well, this number isn't a big number, so it can't be positive 4. It has to be negative 4 because 10 to the negative fourth is a really small number. That's 1 over 10 to the fourth, or 1 with 4 zeros. So there's where all the smallness went. So I like comparing, right? You have a small number, you made a small number bigger. Where did the smallness go? It's like a balloon. If you squeeze the balloon small, that back end will start enlarging because you can't, that smallness or that space has to go somewhere. So that's how we do scientific notation. Okay, this is a great problem. This is pretty advanced for pre-algebra, but it does say honors pre-algebra. So evaluate m times p plus the p root of x plus m to the p power. So we're going to just fill in stuff here. So we have negative 4 times p plus the p root, the third root of x, which is negative 64, plus m, which is negative 4. We have to put parentheses here because we're doing it to a power of 3. So what is that going to give us? Well, we can do what are we going to do? Radicals are a form of exponents, by the way. So we have orders of operations. You have GEMDAS, grouping symbols, exponents, multiplication, division, addition, and subtraction. We don't have any grouping symbols. Yes, that looks like a grouping symbol, but that's just holding the negative with the 4. We do have exponents. This is an exponent. So the third root, I mean, I'm not going to go into radicals right at the moment, but you need to, well, okay, maybe I'll go into radicals. So when you have the square root of 25, most students say, oh, that's 5, because 5 times 5 equals 25. But that doesn't tell you anything. You have a square root. So remember inverses. We try to think of inverses. Addition gets rid of subtraction. Subtraction gets rid of addition. Multiplication gets rid of division. Division gets rid of multiplication. What gets rid of a square root? A square. What gets rid of a square? A square root. Those are inverses of each other. So if I want to get rid of a square root, I need a square in here. So I'm actually going to rewrite 25 as 5 times 5, and then I'm going to write 5 times 5 as 5 squared. So the square and the square root cancel each other, which leaves you with the 5, and that's why the square root of 25 equals 5. Not many teachers teach you that. So it's because the square and the square root cancel. That doesn't come out, it just cancels it. How does it cancel it? Well, it's a perfect square. So here we have a third root. So when we have negative 64, what's going to get rid of a cube root? A cube. Well, 64 can be written as negative 4 times itself 3 times, because 4 times 4 times 4 is 64. That's a cube root. You should know there are certain square roots. You should know perfect squares, and you should know a handful of perfect cubes by the end of your 8th grade year. So square root of 1, square root of 4, square root of 9, square root of 16, square root of 25, square root of 36, square root of what's that, 49, square root of 64, square root of 81, square root of 100, square root of 121, and square root of 144. Those are perfect squares that you should know. You should probably know up to 20. And then perfect cubes, 1, 8, 27, 64, 125. So those are perfect cubes. Oh, and I should do cube roots inside there. Cube root, not square roots, cube roots. So the perfect cube root, so we get the cube root. So negative 4 times 3 is negative 12. Okay, Dad's making a video. Second, all of my family members very concerned about letting me know that they're leaving today. I got my wife, I got my daughters, and then we have negative 4 to the third. So that's negative 4 times negative 4 times negative 4, which we kind of already know is negative 64. How funny is that? So they actually work in tandem of each other. They do not cancel because we're adding and subtracting. So negative 12 plus negative 4 is negative 16 plus negative 64 gives me negative 80. That's a long-winded one, but important. These are things we're filling in gaps. We're making sure you are competent in all things. Things that you covered last year in 7th grade and things that maybe you didn't cover in 7th grade. So when we simplify this, there's a number of ways to do it. We can just multiply the number, hard number, and we can just multiply these and use the spaces, etc. You can convert this to scientific notation. 2.189 times 10 to the 1, 2 to the second times 3.1 times 10 to the 1, 2, 3, negative 3. So we would multiply these numbers together. 2.189 times 3.1. That's 1 times 9 is 9, 1 times 8 is 8, 1 times 1 is 1, 1 times 2 is 2. Move the place value. 3 times 9 is 27. 3 times 8 is 24, plus 2 is 26. 3 times 1 is 3, plus 2 is 5. 3 times 2 is 6. We get 9. we get 15, we get 8, we get 7, we get 6, and 1, 2, 3, 4 decimal places. So it started here, 1, 2, 3, 4 decimal places. So that number is 6.7859 times 10. We multiplied these base numbers. Now we have to multiply the exponents. When we multiply like bases, we add their exponents. So that's 6.7859 times 10 to the negative 1. That could be in scientific notation. Then we convert it to standard. That negative, we're going to move that decimal place. So my answer is 0.67809. No calculator needed. And I did it maybe in 60 seconds. I just made them a little bit easier. You can use either technique. You can do the big numbers, or you can do it in a nice mathematically competent way. Number 23. Number 23. What are we going up to today? Don't tell me 60. What? How many? Ooh, 50 problems? Okay. Okay. We got a couple more to go. Longest, good start for a big, long video. All right. I hate mixed numbers. I'm always going to convert them to improper. Mixed numbers are silly. You don't really use them. Use them from kindergarten all the way up to 7th grade. Once you're in 7th grade, you should start moving towards improper fractions. In 8th grade, we will use only improper. High school, you will only use improper. So let's convert them. 8 times 7 is 56 plus 1 is 57/8, plus that's 27/10 equals tenths, 15, 16, 17/5. So let's move the addition and subtraction first. We're going to convert to tenths here. So that's 34 minus 27/10. These cancel. You're left with 57/8. And 27, negative 27 positive 34 is positive 7/10. Let's multiply by the reciprocal, 8/57. 8/57. And you get x equals, well, this cancels. 2 goes into 8 4 times, 2 goes into 10 5 times, 7 times 4 is 28, and 5 times 57, 35, 285. And I know that that can't be reduced because there was no common factors here. 57 is a prime number, so 7 doesn't go into that. And so that is simplified. There's no other reducing we can do here, so we just multiply across, and we know that this fraction is in its lowest terms. Okay, that's how we are going to be efficient and know when we're done. Some students struggle not knowing when they're done. The ratio of big spenders to tightwads was 5:2. So big spenders to tightwads. So that's going to be 5 big spenders to every 2 tightwads. If 2,100 were big spenders, so new situation, this is situation 1, this is situation 2, how many were there in all? So we want to know how many tightwads were there in this. So we can either look for what number did I multiply 5 to get 2,100, or we can write a math problem. Well, I know that 5 times 420 gives me 2,100, so I can multiply this denominator by an equivalency. So 2 times 420 gives me 840 tightwads. So, but they want to know how many were there in all. So I'm going to add my tightwads I'm going to add my big spenders to my tightwads, and that's going to give me the total number of people, which is 2,940 in all total. spenders. No, total people. We're just going to write total. Okay. There's lots of different ways to do that problem, but that's a pretty efficient way. All right, here we go. We have cubes again. The cube root of -8 is -2 plus square root of 4 is 2. -2 to the third. So this is a little bit tricky. There's a big difference between -2 to the third and -2 to the third. So here we have exponents in both of these situations. The exponent is 3. The exponent is 3. But what is the base? The base is the quantity of -2. The base here is only 2. So the parentheses, Chewbacca holds the negative with it. There's no Chewbacca here. So these are not necessarily tightly connected. So in actuality, we have the base 3 times. Here, we have the base 3 times, but we have it the opposite of the base 3 times. So this is going to be -8. This is going to also be -8, but for a different reason. Okay, so same answer, which I don't like when we do it in this way, but you're going to get that. So very tricky, very important. You'll see it more like -4, quantity -4 squared, and -4 squared. So the quantity of -4 squared is -4 times -4, which equals +16. And then when we have -4 squared, we have the opposite of 4 times 4, which equals -16. So it tends to be when you square that you get students who make that mistake and don't understand the difference between these two statements. So because this is written -2 to the third, that's going to equal -8 minus 4, parentheses, times 3 minus -1 to the 7th. Any negative number to an odd exponent is going to be negative. So we have that. We're not going to do this addition and subtraction. Most students would want to, oh, that's going to be 0. But we don't do addition yet. We have to do everything inside here. So we get -2 plus 2. We can do this quantity, which is -12 times 3 minus -1, which is +1. So we're going to do multiplication before addition. We're not going to do that little, times 3 plus 1. So we're going to do this multiplication, -2 plus 2. -12 times 3 is -36 plus 1. And we're going to do this inside because there's still parentheses, grouping symbols, -2 plus 2 times -35. This is why we're going to do this multiplication before the addition, because we always do multiplication before addition. That's -2 minus 70. 2 times -35 is -70. And now we do the -2, which gives us -72. So that's a great problem to see. Do you understand orders of operations properly? So good problem. Probably lots of students making mistakes there. Again, let's get rid of this. We have 1/6. Let's convert that. That's 7/3 times 1/2 minus 3/4 plus 5/24. I gotta get my posture better. I'm sort of lying back. Lying back? How are you doing that? Well, I have a board and I'm in my house, as you know, because every human being has left the house and let me know. So nothing, we're going to do multiplication before addition and subtraction. Nothing cancels, so we can't simplify that. So that's going to be 7/6 minus 3/4 plus 5/24. Whoops. So we need common denominators. The common denominator of 6 and 4 is 12. So 7/6 equals how many twelfths? Times 2. So that's 14 twelfths. Minus, and 3/4 equals how many twelfths? Times 3 is 9. So that's minus 9 twelfths. plus 5/24. So 14/12 minus 9/12 gives me 5/12 plus 5/24. And nothing cancels again, so that becomes 5/72, right? 6 times 12. Yeah, 5 and plus 5/24. What's the common denominator of 72 and 24? Well, we can do multiples. 72 is 8 times 9, which is 2 times 2 times 2 times 3 times 3. 24 is 4 times 6, which is 2 times 2 times 2 times 3. LCM, what do they have in common? They have a 2 in common. They have another 2 and another 2 and a 3. So they have a 2, a 2, a 2, and a 3, and then a leftover of a 3. So that's 8 times 9, which is 72. So the LCM is 72, so that's not going to change. And then 72, so 24 times 3, so we're going to find an equivalency, 5, 20, 24, 72, so that's times 3 is 15. So that's 20 70-seconds, and then we must reduce it. Can't leave it as 20 over 72, 10 over 36, which equals 5/18. So you have to reduce all fractions in 8th grade. Technically, you have to also simplify in 7th grade. Good, 27, more than halfway there. Now we're going to get into some graphing of inequalities. So if we graph, we have one variable, so it's going to be on a number line, and that number line is going to start with 0, 1, 2, and x is greater than or equal to, and I see x as my solutions. My solutions are greater than or equal to 2. So I'm going to have a closed circle, and my values are greater, go to the right. Notice I don't put this on the number line. I don't put it on the number line because it's very hard to distinguish. It's very noisy down there. I'd much rather have it above. I can see whether it's open or closed. I can see which way the arrow is going, right? If it's on top of it, I don't really see, oh, if a student doesn't write really well, I could be really confused about which way it goes. So I like putting my answers above the number line. Much clearer. You can derive the information that you're trying to convey. 28. What number is 160% of 90? So what number is x? X is 160%, so that's 1.6. Well, we can do this, right? We can do either way. Let's do this. Let's write it on how it says 100. Whoops. Don't want the big marker. 160% of, that's multiplication of 90. Draw a diagram of the problem. Okay, well, I'm going to do it mathematically first, and then I'm going to convert the percent to a decimal by moving it 2 places, times 90. And we get x equals 144. So that is 160%. So there's another way. If we want to draw a diagram, 160%, well, that equals 100% of it plus 60% of it. Well, 100% of 90 is 90, and 60% of 90 is 54. So that's another way that we can do that, drawing a diagram of it. Right? I mean, that's okay, maybe. I don't know. I like that. So that's up for discussion on what you think might be. The number of leaves on the ground increased 240% during the windstorm. If there were 2,700 leaves were on the ground before the storm, how many were on the ground after the storm? So we've got 200 2,700 leaves, and then we're going to increase it by 240%. So what is 240%? Well, that's going to be 2,700 times 2.4. So we can do, that's 0, that's 28, that's 10, that's 0, that's 14, that's 5. 0, 0, 8, 8, 4, and 6. 1 decimal place. So that's going to increase. So you started with 27, then you're going to add 6,480 more leaves to that. And that's going to give me 9,180 total leaves. But how many were on the ground after? Yeah, so were on the ground before the storm. How many were on the ground after the storm? After the storm, 9,180. We are going to add 6,480 to it. Oh, I love volume. Love volume. Love my volume and surface area. So let's duplicate this page, or let's clone it. And let's do each one. So the first one, we're going to do volume. So find the volume. The volume is going to be all of the inside of it. That would be volume of things. So volume of a cylinder. Cylinder is a 2-base figure. So we use volume equals big B times H, where B represents the base area, the circle. So the base area is pi r squared times the height. So whenever you find volume, you have to find out what your base shape is. And the base shape is a circle, so we use pi r squared. So now we're going to fill in 3.14 times my radius, which is 2 squared, times my height. So 3.14 times 4 times 1. 3.14 times 4 gives me 12.56. 12.56 times 1. So the volume of this is 12.56. What's my unit? Feet cubed. And it's cubed because we have 3 dimensions. We have radius squared times the height, so that's 3 units. Okay, that's the volume of the cylinder. Let's do surface area. So surface area is going to be the outside. It's the skin on the outside. And so that's a little bit more complex in the sense that you're doing the outside layers. So we can draw what do you call it? A net diagram. So when you open up that lateral area, this is the lateral area plus, this has 2 bases. So we have a circle and a circle. This is the top and the bottom, top, bottom, and this is plus the 2 bases. So when we find surface area equals lateral area plus base area, 2 bases in this case because it's a 2-base figure. So lateral area is the length times the width. Well, the length of this is going to actually be the circumference times the height. So the circumference, we know that surface area, circumference is 2 pi r. So lateral area is base times height. So we have 2 pi r times the height plus 2 times the base area. Well, what's the base shape? The base shape is a circle, so we have pi r squared. So we know, some people are taught this, that 2 pi r h plus 2 pi r squared is going to be the surface area for every cylinder. No matter what the shape, how big or wide or squatty or tall or cylindrical, we're always going to use that. So that's one way, but I just showed you the logical part. So 2 times 3.14 times the radius, which is 2, times the height, which is 1, plus 2 times 3.14 times the radius squared. So 2 times 3.14 is 6.28 times 2 times 1 is 2 plus 2 times 3.14 is 6.28 times 4. We can pull out that 6.28 and multiply it times 2 plus 4. That's an easier way. We could just multiply those 6.28 times 2 or 6.28 times 4. But I like 6.28 times 6, which gives me 37.68 feet squared. Surface area is a two-dimensional object, and so surface area is just you're multiplying only two dimensions, base and height. So that would be the surface area of that cylinder. More orders of operations. So 31. What are we going to do first? Well, let's reduce that. We can also multiply that. That's negative 15. That's positive 42. This is going to be positive 20. What? Not reduce. That's denominator, numerator. And now we get negative 11 plus 42 plus 20, which is 31 plus 20, which gives us 51. Nice and easy. Make the easy things easy. Find the volume and the surface area of a rectangular solid whose length, width, and height measures 12 inches, 10 inches, 3 inches, respectively. So we have a rectangular prism that looks like this. That is, length is 12 inches, width is 10 inches, and height is 3 inches. So let's clone that page because we're going to do volume first. Let's do volume. Volume is going to be all of this, the inside of it. Volume of a prism is volume equals big B times H. This time the base shape is a rectangle. So that's length times width times the height. So we have length of 12 inches, width of 10 inches, height of 3 inches. So we get 120 inches squared times 3 inches gives us a volume of 360 inches cubed. Did I do that right? 360 inches cubed, yep. Now surface area. Remember, surface area is the outside. So it's the outside skin, not the inside. And we have surface area. Surface area equals lateral area plus 2 base area. Our lateral area is going to be a rectangle, and it's going to be the perimeter around. So it's the perimeter, not circumference, because it's not circular. It's going to be perimeter. So the perimeter is 12 plus 10 plus 12 plus 10 times the height, which is 3. So that's going to be 24 plus 20, which is 44 times 3. So we get surface area equals 44 times 3, and then it's going to be plus the 2 bases, and the bases are also rectangles. So we have two 12 by 10 rectangles. 12 by 10, so plus 2 times 12 times 10. So that's going to be, what is that, 132 plus 2 times 22, so 132 plus 44. 44, did I do that right? No. Yeah, 44, which is 176. I think I made a boo-boo there. Where did I make my boo-boo? Ah, it's not 22. Hello, Mr. Mac. First mistake, and people make mistakes, even Mr. Mac. He is going to make mistakes 12 times 10. That was a sloppy mistake. I added those. That's 120 times 2 is 240, and that gives us 372 inches squared. Much better. Slight boo-boo there. All right, 33. Well, it's a long video. I think we're well hour into this. 33. It's 11:22 on a Friday, June 21st. Mr. Max working over the summer. Use the method of cut and try to find the square root of 20 to one decimal place. This is crazy. This is such a bizarre way. I watched a video on this. I didn't know the cut and try. It's kind of interesting. Trying to remember how to get that, what they did. So I think they found the closest. So we know that we have square root of 16 and square root of 25 and square root of 9. So square root of 20 is here. So we're going to do 4. So we're going to do 4. And then we take the square root of 20 and we minus the 16. And we get 4. And we're going to write 4 over this double, which is 8. We're going to double the 4 from the leftover. Actually, we double the, is it double 4? No, 4 goes up in the top. And then we double the outside number. That's not good. So 4 and 4/8 or 4.5. So you're not going to do, I mean, I guess that's an estimate. If you want to know what the decimal value is, as close as it's going to be, it's an irrational number. So if we do 20 and then do the square root, we get this number. So you see that that number is non-terminating, non-repeating. That's why it's irrational. So there's no fraction that is equal to that. But this is an approximate value. I mean, you're not the square root of 20. To be honest, to be fair in math, you're going to break this into rad 4, rad 5, and you're going to say 2 rad 5. That's the simplified version. That's what they're going to ask for in high school. But I don't know. Maybe they ask you to give a decimal value. It's weird. But this is a good way. It gives you something approximate. But I don't know. That's not that relevant. We're not going to see that often. You're going to simplify it the way that I showed you 2 rad 5 more than you're going to give me a decimal approximation. All right, a number was multiplied by -4. So we have -4 times a number decreased by 6, minus 6. If the final result was -34, what is the number? So we're going to write this as -4x minus 6 equals -34. This is a two-step problem. The inverse of subtracting 6 is adding 6. These cancel. You're left with -4x equals -28. And then -4 is multiplying by the variable. The inverse of multiplying by -4 is dividing by -4. So we get x equals +7. Nice two-step problem that you should be very proficient at coming into 8th grade. 5 times a number is equals 49 greater than the product of 2 and the opposite of the number. So 2 times the opposite of the number plus 49. So if we write that, that looks like 5x equals -2x plus 49. We have variables on both sides. We're going to move that variable over. We're going to combine variables on the same side. The inverse of -2x is +2x. That gives us 7x equals 49. 7's multiplying by the variable. Inverse of multiplying by 7 is dividing by 7. And 49 divided by 7 is 7. You should be able to do these problems that fast. You should look at it and know how to work it. If 4x plus 2 equals 11, what is the value of 2x minus 1? So we're going to take this problem. We're going to find out what x is. We're going to subtract 2. 4x equals 9. And then we're going to divide by 4. and we get x equals 9/4. We're not going to turn that to a decimal. We're not going to turn it into a mixed number. We're going to keep it as an improper fraction. There is nothing improper about an improper fraction. And now we're going to take that value and we're going to substitute it in for the x. 9/4 minus 1. The 4 in the denominator is going to cancel with the 2 in the numerator. That becomes 1. This becomes 2. We get 9/2 minus 1. Let's find like denominators. And like denominators, 9 minus 2 is going to give us 7/2, and we're going to leave it as 7/2. We are not going to change that to 3 1/2 or 3.5. We love improper fractions. So the value of 2x minus 1 is 7/2. Now we're moving, we're cooking with gas. Simplify by adding like terms. I don't like this starting problem. Those terms, there are 1, 2, 3, 4 terms here. Terms are separated by addition and subtraction. They are not in standard form. You're going to be alphabetical order when you write your terms. And we're going to combine those x's, because they're multiplying, and we're going to rewrite that as 3xy squared, and we're going to rewrite that as 2xy squared. Like terms have the same variables to the same exponents. So like terms here, this is a like term, this is a like term. This is a like term, this is a like term, because they have the same variable to the same exponent. And when we combine like terms, we combine their coefficients. Coefficient is 1, so we get 2x squared y. Coefficients are 3 and 2, so we get 5xy squared. And x squared is going to come before x, so that is the correct order for your answer. Use the distributive properties. Distribution is sort of like when you go out trick-or-treating. This gets distributed to each of the kids. Each kid is separated by an addition subtraction, so we have 3 terms here that we're going to distribute this into all 3 terms. So we're going to distribute that 3 times into each of those. So we have 3mn squared times m plus 3mn squared times mny plus 3mn squared times 3m squared. We multiply terms. We multiply their coefficients. 3 times 1 is 3. And then we're going to combine like bases. M times m is m squared, and then the n squared. And now coefficients, 3 and 1 makes 3. Bases, m and m is m squared. N and n squared and n makes n cubed. And then the y. Multiply coefficients, that's 9. Like bases, m to the third, and then n squared. Now, I'm going to put it in standard form. We look at the first variable of each of the terms. M squared, m to the third. M to the third is going to come first. Not because of the coefficient, because of the first variable. Now we're going to look at these. M squared. They're tied. So we go to the n, next variable. N. That's n squared, that's n to the third. So this is going to come next. And then we have our third term, m squared, n squared. This is standard form. This is the proper answer, not shown in the book or the answer key, but that is the proper way to write your answer. Let's simplify. We have like variables. We're going to combine the m's with the m's. We're going to combine the p's with the p's. And when we multiply like bases, we add their exponents. So that's 2 plus 3. And then we have p to the second plus 1 plus 3 plus 1. So that's m to the fifth, p to the 3, 6, 7. And this is in standard form, we're always going to be alphabetical. M is going to come before P. So when we write our terms, when they're being multiplied, we're going to put them in alphabetical order. Write the Roman numeral. Love this problem. Oh, I mean, this reminds me of 5th grade. So Roman numerals, you have 1, you have 2, you have 3, you have 4, you have 5, 6, 7, 8, you have 9, and you have 10. Love those. And then you have other crazy stuff. So 29 is going to be, right, you have 2 10s. So you have, you have X, X, and then you have 9, which is IX. So that's what it would look like, XXIX. So cool. Love this question. It's like Latin. It's a long forgotten technique. So that's a fun one. Glad they went back to that. If Shirley put $4,000 in a bank at 6% interest compounded annually, how much money would she have at the end of 2 years? So you have a couple formulas. You have interest equals principal times rate times time, but that just calculates. This is simple interest formula. And then you have compounding, which is balance equals principal times the quantity, 1 plus R divided by N times to the NT, where P equals principal, R equals rate, N is the number of, what do they call it? Number of times it's compounded, and T is time. So we want to find the balance. The principal is $4,000. 1 plus the rate is 6%, but 6% as a decimal is 0.06, so 0.06 divided by N. The number of times it's compounded annually, so that's 1. That's just one time a year. So that's 1 times and 2 years. So time is 2. So we have the balance equals 4,000 times 1 plus 0.06 to the second power, which equals 4,000. That's 1.06 to the second. Don't know what that is. That's going to be a calculated value. 1.06 to the second power is 1.1236, and we're going to multiply that by 4,000. And that equals that number, $4,494.40. So what we did was we multiplied 4,000 times 1.1236-ish, and that balance equals $4,494.40. That, how much money would she have? That's how much money she would have. Shirley would have after 2 years at a 6% interest rate compounded at the end of each year for 2 years. Love it. 2 important formulas. Simplifying, again, we're back to orders of operations. So we got to know, what are we doing? Oh, we've got negative exponents. We've got negative signs. So this is -1. And we're going to move this. When we change the sign of an exponent, you change the location of the base. Minus, that's negative. That's -2 to the second, which we know is -4, because that's negative, the opposite of 2 squared, because the base, we're doing 2 squared and then that, plus third root, cube root of -27, which is -3. We should remember that from today's lesson. So 3 to the third is 27. That's the opposite of -4. That's +4. That's -3. We're going to do this multiplication. -4 minus 3. That's -31 minus 3 is -34. Boom. So you look at that and you go, wow, Mr. Mac did that pretty fast. He didn't even pause. He just like rattled that off like he's done it a million times. Hey, you know why I'm good? Because I have done it a million times. I've done the practice. I put in the time. I've taken my free throws. I've practiced my free throws every day. Like Caitlin Clark. She practices every day. Like Wayne Gretzky. Like LeBron. Maybe not LeBron. Like Kobe Bryant. Like Michael Jordan. He's super competitive. Like Bryson DeChambeau. Practice, practice, practice. You practice the basics. These are the basics. So when you have to do the more complex and the complicated, you have the muscle memory on the foundational work. Do the little stuff. Use a protractor to draw an 80-degree angle. So this is interesting. I don't know if you did this last year, but you draw a line, you take out your protractor, and you find out where 80 is. 80 is on there, and then has a little tick mark, and then you draw that line there, and that would be 80 degrees. Now, then use a straight edge and a compass to copy the angle. So in order to copy it with a compass, you again draw a straight line, you put a dot there, and you're going to replicate it. You're going to take your compass and you're going to measure this distance with your compass, and you're going to hit a little and so you're going to do that. You're going to go and then you're going to go up there. Okay, so you're copying it, and then you're going to take your compass from this point and you're going to go, and that's how you're going to get that. You're going to measure that distance, and where it crosses is going to replicate that 80 degree. It's kind of hard because I don't have a compass, but that's how you do it. You measure from the same points and you recreate it. It's pretty cool. It's a very neat way of using a compass in order to clone an angle. So you say, well, why don't you use a protractor? Well, the protractor was used just to create any angle. And so we're not using the protractor really. The protractor was just to create an 81. It's just to create the angle. So I don't know. Find X. We have something called similar triangles. So similar, if we name this A, B, C, and we name this L, M, N, those are similar triangles. You would write triangle A, B, C is similar to triangle L, M, N. And what that means are the angles are equal or congruent, is what they say, and the sides are proportional. I don't know if that's how you spell proportional. So we know that the angles are congruent because we see that. Those are congruency signs. That's saying, hey, these angles are congruent. So if they're congruent, that means they are similar. And so we know that their sides are going to be proportional. So we know that this side is going to be proportional to this side. And this side is going to be proportional to that side. So we can write a fraction. So we can look at triangle 1, triangle ABC, and we can do 2 over 5, or AB over AC, and it should be proportional or equal to triangle LMN. So that's going to be 3 over X. And so we can use the cross product. We can write an equivalency. We can go, oh, look at this. 3 times 5 should be equal to 2 times X. And we can write that, and it looks like, let's go back to pen. So 2 times X equals 3 times 5. 2x equals 15, divide by 2, x equals 7.5. Mr. Mac, you said leave it as an improper fraction. You can leave it as 15 over 2 or 7.5. I'm okay with either, but that's more work. So, sorry. Anyone have lunch with them tomorrow? I'll leave the house long before. I have work. Terrifying. Good. Sorry. 45. 6 more problems. Not 5 more problems, 6 more. Solve. So first thing we want to do, we have multiple variables. We have constants on both sides. So what we're going to do is we're going to simplify the sides first. Let's simplify if we can. We're going to combine like terms. We have positive 8, negative x, negative 4x. That gives me 3x minus 2 equals negative 3x plus 14. I always move the variables first. We're going to move the variables to one side, the constants to the other. I'm going to move the 3x over. That gives me 6x minus 2 equals 14. I'm going to move the constant now. We get 6x equals 16. Divide by 6, divide by 6. X equals 16 over 6. We can't leave it as 16 over 6. We want to reduce it. So that's 8/3, and that would be my answer. I'm not going to convert that to a decimal or a mixed number. Number 46, draw a line segment 6 centimeters long. So if we draw a line segment 6 centimeters long, that's a line segment, we'll say 6 centimeters, and construct a perpendicular to the line at a point 2 centimeters from the right end point. So I would measure out 2 centimeters. So let's change this. So I would measure out 2 centimeters. And let's say that that distance is 2 centimeters. And then I would take a compass, and I would take that compass and I would go past half. I'd put one end here, and then I'd go like this. I'd put a little, I'd do an arc, and then I'd keep that distance, and I'd go to the other point, and I would, and that intersection here would create a line, and that line would be perpendicular to, oh, that would be perpendicular 1 inch, sorry. How would I do 2 inches away? So that's going to be 1. That would be 1 inch away, so that didn't, how would I do it at that point? Well, I know how I would do 2 inches out, because this distance is 4 centimeters, so I would do it in that way. I would go, and then I'd do it outside of that, and that would take me 2 centimeters away. So this is 1 centimeter, so that would be wrong. This is 2 centimeters, because that distance from here to here is going to be 4. So that's how you do it. A little tricky part of that. I think I made that mistake. So a little trick, but again, constructing angles, constructing midpoints, those are all very important 7th grade concepts. A single die is rolled twice. What is the probability of the first roll will be a 6 and the second roll will be a 2? We know that probabilities, we know that dice has a 1 in 6 chance of the number that we want. So the probability of a 6 would be 1/6. And when we multiply the second roll of a 2 is also 1 in 6. So the probability of rolling that combination would be 1/36. And if we wanted to do out the combinations, you could roll a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6, or you can roll a 2 and a 1 and a 2 and a 2, 2, 3, 2, 4, 2, 5, 2, 6, etc. And we do 3, 4, 5, 6, all those combinations, down to 3, 6, 3, 1, down to 3, 6, 4, 1, down to 4, 6, 5, 1, down to 5, 6, 6, 1, down to 6, 6, and there would be 6 here, 6 here, 6 here, 6 possible, 6 possible, 6 possible, which gives me a total of 36 combinations. And how many combinations are 6, 2? Well, the 6, 2 is right here. There's only one of them. So that's why we have 1 out of 36 possible combinations. So that would be the probability, 1/36. Love probabilities. Number 48, find A side of P and then find B angle B. Okay, so let's clone that page because there are 2 questions here. So first one, let's find side P. So we have to find side P. It's a right angle. We're going to use Pythagorean theorem. Pythagorean theorem says in all right triangles, the square of the legs will be equal to the square of the hypotenuse. This is a leg, this is a leg, and this is the hypotenuse. So those legs are the sides of the right angle, and the hypotenuse is the side opposite the right angle. The opposite. So we have a leg of 5, a leg of 4, and it should equal the square of the hypotenuse. That's 25 plus 16 equals c squared. That's going to give me 41 equals c squared. What gets rid of a square? Yes, a square root. And if we take the square root of the right side, we have to balance the equation and take the square root of the left side. Square root of 41 is not a perfect square, so these cancel. Square root and square cancel, leaving us with my c. So my hypotenuse is going to equal the square root of 41. And that's going to be between 6 and 7. If you wanted to find a decimal value, we could do that decimal trick. You want to try it? Yeah, let's try it. 41, so square root of 36 equals 6. So we're going to subtract 36 from 41, that's 5. So 5 5/12. 5 divided by 12 gives us 41. So like 4.16 repeating. And now let's see, square root of 41. 41 square root 6. Oh, yeah, approximately. It's not bad. So approximate, let's use our approximate number. Okay. Yeah, I mean, if you want it, it's there. But this is the right answer. Ooh, that is the right answer. That's what you're going to give. Alrighty. Almost done here. Let's find angle B. What do we know about the side or the angles of a triangle? The angle of every triangle adds up to 180. So we know that this is 90 degrees. So you have B plus 42 plus 90 should equal 180. So we have B plus 132 equals 180 minus 132. B equals 48. Borrow 48 degrees. So B is 48 degrees. There you go. Oh, yeah. Oh, baby. This was pretty awesome. All right, so I had to do this a little pre-front. So using base 10. So base 10, right? 75 base 10 using base 2 numerals. So base 2 numerals is really binary. It's either 1 or 0. So you either have a 1 or a 0. So in each of the units. So 1 would be there. That would be our first number. And then our next number would be a 1 in the tens place and a 0. So using 1s and 0s, we would go 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, and then 0, 1, 1, 0, 0. And so we're increasing each flip, and we're just going increasingly. So if we do 75, I kind of see this pattern that's going on how many numbers. So we have 1, 2, 4, 8. We're going to do 16 of those. And so I kind of extrapolated it out. Instead of writing to 75, I just kind of knew that we would get to 7 places. 1, 2, 3, 4, 5, 6, 7 would start at 64, and then we can go to in that order. So we have 0, 1, 10, 11, 100, 101, 110, 111, and then we increase to 1,000, 1,001, 1,010, 1,011. So it's kind of cool. It's binary. It's neat. You can have base 3, base 4, and it's pretty nifty. So I like base. It's just very, and computers use binary. Everything. What do they call? I don't know why I was supercomputers, but capacitors. No. God, what are they called? Processors, chips, microchips. All those chips are just gates having on or off, and on or off is binary, 1 or 0. So binary is cool. If you're a programmer, you should learn binary code. Back in the day when Mr. Mac was in, ninth grade, when I was a freshman in high school, which was in 1981, I took computer class and we had to program using binary. So that was kind of fun. So back in the way back machine, when Mr. Mac was working on TRS 80, Trash 80s, he used to have to program in BASIC. All right, last question. Super easy. We just went from very interesting question to a relatively simple question, graphing. Graphing is on an x-y coordinate system. Our x comma y, it's always going to be alphabetical. So our x-axis is 4, and then our y-axis is -3. So we're going to go 4 on the x, 1, 2, 3, 4, and then -3 on the y, 1, 2, 3. So that would take us to this location, and this would be the point 4, -3. And then b would be -3 on the x, 0 on the y. So we would go -3 on the x-axis, and then 0 on the y. We would just stay there, and that would be the point -3, 0. And you should definitely know how to do your coordinates on a coordinate plane. And there you go. Those are all the answers. If you want to see them, it's also there. I think I show these are a little bit different order. These, you would never write y before x, so those are improper. And there's your construction of angles. Here's your construction of perpendicular, and your other, and then there you're graphing. So, all right, long video. Appreciate you being here, and appreciate you checking your work and doing these pre-algebra shore up problems. Have a great one.